Notes 9.1, scatter plots and lines of best fit. So this is our 9th chapter on statistics. And with statistics, there comes a lot of vocab words. So we've got 4 to start out with here. So what is qualitative data or categorical data? Okay, 2 big words. But I try to sort of pick the word apart a little bit. Okay, we've got quality in there, okay, that prefix, and then category. Okay, or quality or category. So let's write that down. Quality or category. So if you were to categorize something or talk about its qualities, you might talk about its color, okay, shape, okay, would be types of qualitative data, different types of items, okay, cars, different car types, trying to think what else, okay, nothing to do with numbers, in other words. So then numerical or quantitative data, so let's write that in there, numerical or quantitative data, and then let's pick that apart. Okay. So we have the word quantity, okay, within the word quantitative, and numerical, that N-U-M-E-R, indicates numbers. Okay, so quantity or numbers. So what do we mean by that? Okay, heights of people, sizes, anything to deal with numbers would be considered quantitative data. And that's the data that we're going to use the most of, and next year you'll spend a lot of time with that type of data, the number kind of data. So now what do these other 2 words mean? Bivariate, okay, and that prefix bi, V-I, means 2, okay, and variate means variables. So 2 variables. And you're used to 2 variables, the x and the y. Okay, when we graph things, we use 2 variables, x and y. Outlier. Okay. An outlier, okay, that O-U-T, out or outside, it's a value that is much smaller or larger than the rest of the data. Okay, an outlier, something that's outside, okay? It's not close to the other numbers. So now we've got, it says, describe the association between the bivariate data shown in each scatter plot. Okay, so we've already jumped in and used one of our words, bivariate, okay, 2 variables. So we've got like an x and a y axis here, and we've got a scatter plot. A scatter plot, okay, that definition kind of fits into the way these graphs look. They're just points or plots scattered about the graph. And it says an association can be strong or weak, it can be positive or negative, and it can be linear or nonlinear. So all of those words you are familiar with. So when I look at graph A, this first one, and these points look like they're going downhill, okay, and they're pretty close to a line, and they're all kind of close together. So I would say because they're close, oops, I should change that. They're all close together, so we should say that it's a strong association. And because they're going downhill, okay, that's negative, a negative slope. And they look close to a line, so we would say that they are linear. And then in this next graph, okay, I start to say to myself, strong or weak? Well, they're all kind of spread out all over the place. Do they look like they're going downhill, or do they look like they're going uphill? And they really don't. And then I say, does it look like we have a line here? Or does it look like we have another shape here? I really can't pick out any kind of shape. So I would say that the association here is very weak. We can't make any sort of predictions from here. On graph C, I start to ask myself those same questions again. Strong or weak, positive or negative, linear or nonlinear, and does it fit in here? Well, it kind of looks like maybe it's going downhill. It's kind of a stretch. So I would say that maybe it's moderately weak, okay? Or moderately negative, sorry. Okay. We really can't attach whether it's linear or nonlinear. And then, like I said, it's strong and weak might be too powerful a word, so we're going to say this moderately, so-so, okay, negative. Then when we look at this last graph, we ask ourselves those three questions again, strong or weak. So do those points look close together? And they do. So I would say that it's a strong relationship. And now do I say, do they look like they're going uphill or downhill? And they definitely look like they're going uphill. So we'd say that it's positive. And then linear or nonlinear? Do they look like they're forming a line, or do they look like more like they're forming a curve? And I would say that they look like they're more forming a curve, so we're going to say that they're nonlinear. Okay. So now I've got a table. There are actually two tables, but it's one set of information. It says the table shows the results of 10 students throwing a ball. Okay. So we've got the height in centimeters, which is our x, and then the distance thrown of this ball from each one of those students. Okay? So it says construct a scatter plot for this data, and it tells us how we should set up our grid. It says use 1 centimeter on the horizontal axis to represent 2 centimeters of height. Okay, so that's our x. And then 1 centimeter on the vertical axis to represent 5 meters, okay, thrown. So let's go down here and so we know that our height is down here on the horizontal axis, and that's in centimeters, and that's our x-axis. And we also know that the distance, is in meters, and that's our y-axis. Now it also says, it tells us how to set up this grid. Okay, so it says the height, use 1 centimeter on the horizontal axis to represent 2 centimeters of height. So here's a centimeter, so I'm going to mark these off. Each one of those bigger boxes, okay, represents a centimeter. And they tell us, okay, and use 1 centimeter on the vertical axis to represent 5. So we're going to mark off those big boxes. And now when I go back to my height, what is the shortest person here? Okay, the shortest. All right, the shortest person looks like, okay, is 154 centimeters. So now, it says here, okay, we've got to count by 2s. Well, I certainly can't start at 0, okay, but we know 0 is right here at the corner. So we're going to put that little break in the data there, okay, to represent everything else leading up to that. So I'm going to start with, okay, so what if I start with 152 there, all right, and then 154, and then we're counting by 2s, because that's what it told us to count by. And I got up to 170. Does that cover all of the heights? It looks like the tallest person here is 168, so I'm good. Now let's go do the distance. And they said to count by 5s. And the lowest distance is 48. Right? So 48, but they said to count by 5s. So okay, I'm going to start this one at 45. Okay? And that break in the data is going to cover the distance from 0 to 45. So now I'm counting by 50s. Or I lied, counting by 5s. And I got all the way up to 80. And let's make sure that 80 covers the distance thrown. So it looks like the furthest distance thrown was 70. So I'm good. Okay, so now let's go ahead and plot our points. So my first point is 154.48. So 154 and then 48. Well, 48 is not on my graph, but I go from 45 to 50 if you count in between. So 154, 46, 47, 48 should be right there. It says 49, and then that line is 50. Okay. And now the next one is 160, 50. Next point I'm going to plot. 160, okay, and they threw 50. Okay, so go ahead and pause the video, plot all the rest of those points, and then come back. Let's talk about that next one I just realized. So 160, 160. So 161, okay, is right in between, okay, but we don't have even boxes in between, so just, it's a nice estimate, okay, so just be nice, somewhere nice in, right in between 160 and 162. So 161, and we're going up to 60, I'm going to place it right there. Okay, now pause and graph the rest. Okay, so I have my scatter plot drawn, so you know how to make a scatter plot. Okay, so now let's go ahead and turn the page, and we've got another definition. Okay, what is a line of best fit? So when you look at that graph that's right below that definition, you see a line and you see a scatter plot. Well, that right there is a line of best fit. So what is exactly the line of best fit? Okay, it is a straight line that best represents the data on a scatter plot. Okay, it is used to predict information not on the scatter plot. Okay? That best represents. Okay, so it's not exact. Okay? Best represents. So now let's use the scatter plot and this line of best fit to answer some questions. It says, write an equation for this line of best fit. Okay? So to write an equation, I need 2 points. I need the slope, and I also need the y-intercept. Okay? So we know how to find that information. Okay, so you could pick 2 points. All right. Now, the 2 points I pick may not be the same 2 points somebody else picked. So that's why it's considered the line of best fit. Okay? Everybody's could be slightly different, but still be good predictors. So I'm going to pick those 2 points right there. And this point is 75.18. And this point here is 85.60. Now, like I said, you may have picked 2 other points, or someone else may have picked 2 other points, but our equations are going to be very close to each other. They may look a little bit different, but they're going to be very close to each other. Okay? So now I can find my slope, and then I can also find this. We can see approximately where it crosses the y-axis. Okay? There's our y-intercept. So let's do some calculation here. So let's do our change in our y over our change in our x, or our rise over our run. Okay, so the change in the y going from 16 minus 18 over 85 minus 75. My rise over my run, that's all I've done right now. And I've got negative 2 over 10, which simplifies to negative 1/5. So that's my slope. Okay, so I've got that. So I came up with 2 points. I came up with the slope. And now, what's the y-intercept? Right there, approximately, okay, my y-intercept, or my b, is 24. So I can write my equation. I have my 2 pieces of information that I need to write y equals mx plus b. Y equals slope x plus y-intercept. So that is my equation of my line of best fit. So I'm even going to put that on my line. Okay. Now it's an estimator because, like I said, everybody's could be slightly different. So now even what it says in the question, use your equation to estimate the yield in grams of a chemical reaction when the temperature is 90. So temperature is my x, and then my yield in grams is my y. So right now they're asking us to find the yield, which is our y. So we're looking for y equals, so now use the equation, negative 1/5 x. Well, our temperature is 90 plus the 24. You're going to go to your calculator, okay, and get that number, and that number should be 6. Okay? So at 90, okay, it should be 6. All right, now that's, I'm going to pause and I'm going to double check that. Okay, I'm going to backtrack a little bit because when I got that 6 for my answer, when I went back to my graph and I went to 90 and I went up and I went to touch my line, that was nowhere near 6. Okay, 6 would be somewhere down in here, and that's absolutely not true. So let's backtrack a little bit. Let's just erase, okay? Let's erase this. And my problem is this guy right here, my y-intercept. So let's go back and rethink the y-intercept for a moment, okay? That won't take long. So let's do some calculation to get our y-intercept. So let's use one of our points, okay? And I think I'm going to use that 75/18. So if my y is 18, my slope is negative 1/5, and my x is 75 plus b. Let's do this calculation and see if we get a better y-intercept, because I think mine was a little bit too off. All right, so pause and let's do that calculation. So that negative 1/5 times 75, I don't know that off the top of my head. 15, there we go. Okay, 15 plus b, oops, negative 15. Okay, now we're getting a little bit closer here, okay? All right, so if I add 15 to both sides, I get b is 33, okay? So now I just need to change my y-intercept in my graph. Y equals negative 1/5 x plus 33. Now let's use that guy, okay? So again, I'm looking for my y, negative 1/5 of 90, okay, plus 33. Okay, so negative 1/5 of 90, so that should give me a negative 18 plus 33, okay? So what is negative 18 plus 33? Sorry, I had somebody at the door there. Okay, so my y is equal to 15. Okay, 15 grams it would yield. That's better. All right. Okay, now the last question says use your equation to estimate the temperature. Okay, so now we're going to look for the x when the yield is 20. So we're going to say 20 equals negative 1/5 x plus 33. Now let's solve for x. Okay, so we're finding the temperature of this now. Okay, how do I undo that? I could multiply both sides by -5. So I get x is equal to, and 5 times 13, okay, would give me 65 degrees. All right, nice job, guys.